helped you in understanding the concept of solution. Let's take a quick brief about that lecture. In that video, we have done the definition of solution, what kind of mixture it is, what kind of particles it contains, and then the type of solution on the basis of type of solvent, and the nature of the solvent, that is solid, liquid or gas. Then we have done the concentration terms, that is percentage, molarity, molality and mole fraction. Today we will be dealing with the concept of solubility of the solutions, and particularly with the solubility of liquid solutions. So let's take a look. The first thing we'll do is solubility of solution of solid in liquid. Whenever you are mixing any solid in the liquid, then how can we define the solubility term? For that, you must know the two concepts. One is dissolution, other one is crystallization process. Now, what is dissolution process? Whenever you are mixing any of the solute whenever you are adding any of the solid solute into the liquid solvent, it results into the formation of solution, and the process is known as dissolution process. For example, you are mixing sugar into the water. The process is known as dissolution process. But you know very well that after some time, if you are adding more of the sugar into the water, it stops mixing into the water, and that point is known as saturation point. That after certain limit, no more solute can be added, and after that what happens? The extra sugar particles will separate out from the solution, and that is known as crystallization process. So what is dissolution? Whenever you are adding solute into the solvent and forms the solution, that is known as dissolution. But after saturation point, if the solute particles separates out from the solution, it gives back solute and solvent, and the process is known as crystallization process. So now we can define the solubility, which is solubility can be defined as how can we define the solubility? It is the maximum amount of solute that can be dissolved in given amount of solvent to form the saturated solution, right? So till the saturated solution we get the solubility, because we know very well that after saturation the more solute cannot be added. Now further, the solubility of solid in liquid depends upon the two factors. That is factors affecting the solubility of solid in liquids. Number one factor is nature of the solute and the solvent. Nature of the solute and the solvent. So for that we know very well one concept, that is like dissolves like, which means the ionic compounds dissolve in the polar solvents and the non-polar compounds or covalent compound dissolves in the non-polar solvents. For example, common salt, that is NaCl. Common salt is more soluble in water than the sugar. Why? Because common salt is an ionic compound, and on the other hand, sugar is a covalent compound, and water, it is a universal solvent which is polar in nature. So ionic compound dissolves more in the ionic compound, that is polar molecules, and covalent compound is less soluble in water molecules because like dissolves like. But what is the reason behind that? That why ionic compound dissolves more in water but not covalent compounds? The reason behind that is hydration enthalpy. Hydration enthalpy. And for that, we must know the lattice enthalpy. Hydration enthalpy and lattice enthalpy. Hydration enthalpy means whenever you are dissolving any of the ionic compound to the water, it dissociates into its ion, Na positive and Cl negative. Now what will happen? When Na positive and Cl negative dissociates into its own ions, then the water molecules in which oxygen is carrying partial negative charge and hydrogen is carrying partial positive charge, this water molecule surrounds the ion in that way that the opposite charges attract each other. Like Na positive. So oxygen has a negative charge. Now the water molecule will surround itself around the Na positive so that partial negative charge and positive charge attracts each other. On the other hand, here H positive will be inward and O negative will be outward as negative and positive charges attract each other. So this is how water molecule will surround the Na positive and Cl negative will surround the Cl negative will be surrounded by water like this. This is known as hydration enthalpy. But before hydration enthalpy, lattice enthalpy comes into play, which means the enthalpy, the energy required to break the lattice, that how much energy we require to break the NaCl. So as a result, the lattice enthalpy should be less than the hydration enthalpy, then only solubility can occur. Which means the energy required to break the lattice should be less than the energy released when the ion is hydrated by the water molecule. So this is how the nature of solute and solvent affects the solubility of solids in liquids. And the next factor is the temperature. Now for the temperature, the solubility solubility of the solid in liquid categorized into three categories. Number one category is the compounds whose solubility increases continuously with increase in the temperature. For example, NaCl or KCl. In general, if we talk about this, if we are increasing the temperature, that we are increasing the kinetic energy of the particles, which as a result increases the solubility. That is why the maximum compounds comes under into this category. Why? Now the question arises, why? The reason is its dissolution process was found to be endothermic in nature. The dissolution process was found to be endothermic in nature. How we can describe this? If we are mixing solute and solvent and the reaction is endothermic, so it means according to Lee-Chatelier principle, the reaction will move to the forward direction if we further increase the temperature. Or we can say if the reaction is endothermic in nature, so the forward is endo and the backward is exo. So now if we increase the temperature according to Lee-Chatelier principle, the reaction will tend to move in that direction which can absorb this temperature or heat, and that is endothermic. So that is where the reaction will move in forward, and we know very well that the forward reaction is always dissolution, that is solubility will be more. And the second is the compounds whose solubility decreases continuously with the increase in the temperature. For example, Na2CO3.H2O. Now what happened in this case? It was observed that dissolution process in this case was exothermic in nature, which means if you are adding solute into the solvent to form the solution, the heat will be released. Which means that the forward is exo and backward is endo. Now if you further increase the temperature, the reaction will tend to move in that direction, which can absorb the heat. And you know very well that endothermic reactions are reactions which can absorb the heat. So the reaction will move to the backward direction, and backward direction is crystallization process. So the solubility will decrease. Clear? So the first one whose solubility increases continuously, and the second one whose solubility decreases continuously. Now the third category, and the very important category, is the compounds whose solubility neither increases nor decreases continuously with temperature. The compounds whose solubility is neither decreasing nor increasing with increase in temperature. So the temperature what we are giving, then what it is doing to the salt or the compound, वो क्या कर रहा है? Salt को अगर हम temperature उसको provide कर रहे हैं, right? So for that, the reason is either it is changing one polymorphic form to the another, or hydrated salt to the anhydrous salt, or more hydrated salt to the less hydrated salt. For example, we take the example of Na2SO4.10H2O, which is known as Glauber's salt. Now what was observed? When the temperature was given to this salt, then the above 32.4 degrees Celsius, it changes to its anhydrous form. But when the temperature was decreased again, that is below 32.4 degrees Celsius, it comes back to its on state, that is the hydrated state. And this temperature is known as the transition temperature, in which one form of the salt changes to the another form of the salt. So it means that here the solubility is neither increasing nor decreasing, but the temperature what we are giving is changing one form of the salt to the another. So this is how we describe the solubility of solid in liquid with the help of dissolution and crystallization process, and then further the factors affecting, that is nature of solute and solvent, and the temperature on the solubility of solids in liquids.